in the past, we have contributed to the project with packet capture acceleration. So in essence, we have decided to, because this was also our problem, to accelerate Suricata by providing integration with a library that we created that is called pfring with zero copy drivers that in a way are pretty similar to what is the PDK doing today. So more or less, they solve the same problem. And we have also shown that we have integrated our tools with Suricata because Suricata is a command line application. You see, it's a source of data. Okay, so in essence, in this AI days, it is a way to extract the features from packets. Okay, that somebody else is going to classify. So we have created this integration with ntop, that is our tool, our visual tool that is still is an open source tool that is able to receive data from Suricata event log to ntop to display them into a user interface and eventually turn them into email, alert, whatever makes sense. This is what we did. Today, I'm going to talk about something totally different. As Kelly said that the OISF has a lot of money, we have decided to donate this time some work and some code. And this is what we have been doing for more than 12 years now. It's a DPI toolkit. So what is the motivation behind this work? Okay, Suricata supports about 20 protocols, if I'm not wrong, and most of them are RFC-based. So in essence, there is an RFC that describes them, and that is fully documented. It is used by, by the operating system. Unfortunately, today, there are many protocols that are not RFC-based, but that people take for granted. For instance, if I speak with my daughter, and I ask her, is the internet working, the internet connectivity is working, she doesn't do a ping, but she opens YouTube or Instagram, this type of things, right? So Instagram, for many people, it is a protocol. Facebook, it's a protocol, this type of issues. And because we have many times, we are monitoring networks, so we're monitoring traffic. We are not security guys. Security is one aspect of the thing. So we need to deal with things like, is my printer really a printer or not? So if your printer makes Instagram traffic, probably it is not a printer, right? So these type of things that are somehow easy to do because you take TLS, you decode TLS, you take the client hello, so you take the name like Eric has shown, and you compare it with a database of domain names, are somehow complicated with Wireshark. You have to write rules like this, and probably there are many domain names. So we think it's time to automate this. And then there are some protocols such as Tor, the onion ring, or crypto miners. Okay, so I would like to say, if I see crypto mining traffic, alert. Simple, as simple as that. Or for instance, if we see, detection of non-trivial things such as a domain-generated algorithm, so DGA, so those funny domain names very, very long. Or if I see a domain name written in Punycode, so in essence, it includes some letters that look like the standard letters, but they are not. Okay, that a computer can decode it properly, but probably there is something behind it. Or for instance, another thing that is somebody using a VPN in my company that is not a corporate VPN, for instance, OpenVPN or WireGuard, but is using something like those VPNs that are trying to hide security, like NordVPN, just to give an idea. And we would like to see in Suricata the ability of detecting them easily. So write a simple rule. I don't like those things in my company, corporate, very easy. We have seen that it's very hard, at least for us, to follow up this trend of rules because the traffic is complicated, it's constantly changing. So we thought that it was easier for us to put the intelligence somewhere else. And another thing that we believe that it would be nice to see in Suricata would be to trigger alerts, okay, out of the box about certain things. For instance, suspicious patterns, okay? So for instance, you see a protocol, you see a traffic flow in the network that you don't know, not even a DPI toolkit knows, but it looks encrypted. This is probably unexpected. If you see, in particular, this traffic that is going to a remote country or a remote host with whom you never talked before. Or for instance, trigger an alert when you see traffic that contains insecure ciphers, for instance. Okay, you know the list of ciphers, but somebody has to maintain it. You have to maintain the rules. I mean, it's a long story. Otherwise, another common pattern is you see obfuscated traffic or double encrypted traffic. Last week, we were in Austria at the Wireshark conference. We were given a presentation about traffic fingerprinting. And we have explained that it's pretty common to see now traffic that is encrypted twice. So you open the TLS, and you say, oh, I'm done. No, you're not done at all, because there is something else encrypted. So if the traffic is encrypted twice, why this? Okay, there should be a good reason for that. Identify malware also, we have seen the story of JA3, JA4, and of course have traffic fingerprints. SuriCata supports a few of them, but it does not support all of them. And just to complete, the reason why we are here today is because we would like to complement the existing signature-based engine of SuriCata with some behavioral traffic analysis that SuriCata does not have. So I think this would be nice. Also to move from about 20 protocols to about 500 protocols, okay? So this is why we are here. So in essence, we like this community, we are using SuriCata, and we believe that there is a benefit in merging these two types of technologies together into the same tool. We are not first, okay? So for those who attended the SuriCon in Athens, you have seen that the ENIA has done this sort of integration. But that code is not open source. That code is not part of SuriCata. It is probably expensive, I don't know. And so this is not what we want. What we want to create something that is inside the tool. It is open source. Everybody can use at no cost. And to be very honest, we are here today also because we would like that somebody starting to use this tool can contribute to the DPI library. So in a way, there is a win-win situation that allows us to increase the number of protocols, increase the detection. What is nDPI? As I've said at the beginning, it's a library that we are developing since 2012 that is all written in C, so there is no Rust. Sorry for the Rust guys. So it is open, okay? So it contains about 450 protocols. And some of the people in this room contributed. For instance, Philippe Antoine gave us a lot of help years ago when he said, Luca, it's time to do fuzzy checking, and he was completely right. Because this library is at the bottom, on top of which other applications are relying, so it has to be reliable too. So thank you for that. And it is used by companies, so it is not used just by us. For instance, Sophos is using in their tools. It is LGPL. It is open source. It will be open source. This is the idea. So we want to maintain it like that. It contains many protocols implementation. Again, don't think about RFCs. So for us, a protocol it has a broader meaning. It doesn't mean only the standard protocols. It is a DPI library that is running on top of IP. So from IP up is there, if you want to detect ARP, Cisco Discovery Protocol, this type of things, it is not interesting, but I think it's not interesting either for this community. In nDPI, a protocol is divided in two parts, a major and the application protocol. So for instance, in this case, there is quick YouTube upload. Quick means that the transport, it is quick, or can be quick, TLS, for instance. And in this case, YouTube upload means that somebody is uploading a video to YouTube. So there is the companion protocol YouTube, that it means that you're watching something on YouTube, okay? It is, unfortunately, it is not standardized DPI. There is no IETF implementation. So every DPI toolkit has its own numbering, its own list of protocols. So this is not an option, an exception in our case. And today we implement most of protocols that are modern, let's say. For instance, everything today is most of the time based on quick or TLS. So in essence, today doing a DPI means that create a long list of protocols and do some matching. Like you see, this is the case for Netflix. You see, if the domain name inside the traffic is Netflix, this, netfliximage.com, blah, 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 this is Netflix. So this is what a protocol is in nDPI. And of course, you can customize it, and you can create new protocols at runtime, simply injecting into the library through a configuration file the list of protocols. For instance, if you have an old mainframe that is picking a funny protocol on a port, whatever, you can define this inside nDPI, and this will become a protocol. Okay? It doesn't have to be implemented in C. In C, we have implemented the main dissector, so the main code. Today, it is mostly configuration. So whenever you see something like that, it is very, very easy to extend. The traffic classification, it is very simple. So we start from the first possible match. So if we see a TCP port 80, we start from HTTP. If it doesn't match, we'll skip and we'll move to other type of dissector. Usually with 8 packets, you can do the job, even though we have recently introduced in the latest nDPI version, something called first packet matching. So the goal is for us is to go towards one packet that does the matching. We don't have time to talk about that, but I can explain. So at the moment, an upper bound can be 8 packets in general for TCP. For TLS, that is one of the protocols that takes more packets. Otherwise, besides the three-way and shaking, a couple of protocol packets should be enough. In addition to that, we have something called flow risk. That is the ability for nDPI to analyze the traffic and to detect issues that we believe are meaningful for security into the traffic, okay? Like, you know, for instance, very simple thing, SQL injection, just to give you an idea, or weak cipher. You know, at the moment we have 56 of them, so we are improving them, and they are reported along with the protocol. So if you see traffic, you see Facebook, you see, you know, unknown cipher or things like that. And of course, we have support for ETA, encrypted traffic analysis. That is a nice thing. I mean, I believe that encryption has a lot of opportunities, okay? It has also some shortcomings, of course, but it has also the ability to give us things about the sender, the one who's talking to us. And we have analysis of behavior ETA. So it means an application that is using TLS in a way that is unexpected. Again, we don't have time for that, so I leave the stage on to Alfredo.
Thank you. Hello, everyone. So what you see in the picture here was the first integration of nDPI in SuriCata that we implemented the last summer. This was just a proof of concept that we implemented to demonstrate that it was easy to integrate nDPI in SuriCata. Then, also talking with the SuriCata core team, we realized that it was better to implement this as a plugin, an external plugin. So at the end, we came up with this plugin. But this requires the introduction in SuriCata of a few hooks, callbacks in the code to be able to, again, integrate nDPI or other nDPI-like plugins with SuriCata, because nDPI is a deep packet inspection library and requires access to the packet payload and requires some state in the flow for storing information about the dissection. So for this reason, we required a few callbacks in the flow lifecycle, also references in the thread or in the flow objects to keep nDPI data structures, because we have a global handle, global per thread, I mean, to keep all the nDPI stuff, and then we need data structure per flow to keep the status of the dissection. And also a callback in the Eve JSON builder to be able to augment the exported information with metadata coming from nDPI. Of course, thank Jason, I don't know where is him, for implementing all the support for this plugin. Thank you. This was most of the work. The nDPI plugin is really short. So here we have the main 3 callbacks that have been introduced to support this work in order to call the nDPI engine at the flow initialization to allocate the nDPI data structure. Then another call every time a packet is received in order to actually run the deep packet inspection engine on the packet payload. And one more call when the flow terminates, let's say, to free the data structure. And one more callback for adding the nDPI metadata in the Eve output. So this is called just after the JSON object has been filled by SuriCata, and it's turned when it's time for nDPI to add additional metadata in this JSON. So this is an example. This is the Eve output, and at the end we have this nDPI sub-object that contains nDPI metadata. Now, probably this is not the best example, because in this case the main protocol was TLS, which is already supported by SuriCata, so most of the information here are already extracted by SuriCata. but it's the same for all the other protocols. So here you see the application protocol, actually the transport.application, as Luca said before. We also export the category, in this case social network, which is because this is Facebook application protocol on top of TLS. The confidence that tells us if this protocol has been detected by a dissector in nDPI, or if nDPI is guessing the protocol based on the port, for instance. And then the breed, if the protocol is safe, unsafe, if it's about fun or other. Okay, it's encrypted. Then we have the server name and other TLS metadata, including the JF3, JF4, the cipher, and other information. And we also have the flow risks. Now, in this case, it was empty. So it's a list of risks detected by nDPI on the flow. Now, in 2019, we presented SuriCon, the ntop integration that Luca was talking before. So the ability to merge visibility provided by ntop with security, so with threat detection provided by SuriCata. So it was possible to run ntop on a traffic mirror, SuriCata on the same mirror. ntop was detecting the flows, the protocols, application protocols with nDPI, etc. And then was correlating this information with alerts coming from SuriCata. So you had in a single place traffic monitoring, visualization, and alerts. Now with the new nDPI integration, SuriCata became a first-class sensor for ntop. So you can process the traffic just once in SuriCata, which is exporting alerts, but also exporting flows. In SuriCata, this is called netflow. You can find it in the YAML. And with nDPI, it also exports the nDPI metadata, so the application protocol. So the result is like this. So in ntop, this is ntop receiving if JSON logs from SuriCata on a syslog interface. And here you see the flows that comes directly from SuriCata using the netflow export. And we also have the application protocols detected by nDPI running on SuriCata. Otherwise, it was impossible to run nDPI in ntop when collecting flows from SuriCata because, of course, we don't have access to packets, to the packet payloads. But this way, we can do that. And we also have extra information like the server name on the last column, for instance. And of course, we still have the alert information coming from SuriCata, as you can see at the bottom of this page. And in addition to the metadata coming from SuriCata, we also introduced new keywords that you can use when writing signatures. For instance, the first one is nDPI protocol that lets you match traffic based on the layer 7 protocol detected by nDPI. So you can specify here nDPI protocol, I don't know, in this example, I'm using DNS over HTTP or TLS. You can specify just the application protocol or the transport protocol or both. So you can specify TLS.Facebook. And this will match the traffic on any port, of course. So this is the list of built-in protocols that you have in nDPI that you can specify with that keyword. So within in this keyword, nDPI protocol. Those that you see here, of course, are the built-in protocols which are natively detected by nDPI. But as Luca has shown before, you can extend those protocols with custom protocols by specifying, I don't know, a host name, a combination of host and port, or we're pretty flexible. Another keyword that we introduced with this plugin is the nDPI risk. So the ability to match traffic against one of the risks, flow risks, which are detected by nDPI. For instance, here we have a simple rule which is detecting the nDPI protocol, HTTP, and the risk binary application transfer. So this means that we have a binary application transfer on HTTP protocol. And this is the full list of risks that we have today. Those in red are detected on encrypted traffic, so almost half of them are detected on encrypted traffic. Yeah, I don't want to bother you with the full list also because we don't have time. So to wrap up, with the nDPI integration, we introduced a few things. So the ability to augment what Suricata is already exporting in terms of metadata, and also add the ability to extend the signatures at the layer 7. So this should simplify a lot when you write a signature, as Luca said before, and makes everything, I think, more effective. Yes. Now, performance. This doesn't increase too much the memory utilization. nDPI is using around 1 kilobyte per flow, and nDPI runs at the beginning of the flow, so for the first packets until the protocol is detected. Then this memory can be released. So it's the impact on the memory footprint is really low. Also in terms of performance, nDPI doesn't use too many CPU cycles. We use it in our 100 gigabit sensor, which is able to process more than 1 million packets per second in 12, 16 cores, depending on the CPU. So we run some tests with our sensor, and introducing nDPI in the sensor, enabling nDPI in the sensor, increased the CPU utilization about 5% probably. The plugin is on GitHub, waiting for approval, but it's in a good state, I think. There is also a ticket on Redmine. There is still a lot of work to be done if you want to discuss about this.
Yes, this is just the beginning of the integration. So in essence, there are other things that we need to do. So for instance, we need to add more signature words, okay? For instance, the breed. So you can say, if this protocol is not harmful, ignore it, things like that. And we also want to export, some metadata and to have something similar to, quick and safe cipher equal 1, then whatever. And then we want to also do things that for us are standard, but are not standard in this community. For instance, we have seen the rules. The rules are flat for everybody. But if you have a device that it's old and outdated, you cannot upgrade, why does it have to generate so many alerts for things that are normal? So to have something also possible to have the ability of turn off some of those alerts for specific devices, we call exceptions. Or for instance, to use fingerprints to check funny combinations. So for instance, if you have a Windows source that is doing connectivity check android.com, so probably there is something wrong, okay? So to have the ability of doing this into the rules. And then also, nDPI can be extended. As we have said, it is possible to load some files at runtime. So we need to be able, like, for instance, the blacklist, okay? So this is something that we need to do, and we need probably to modify the YAML file, but again, we wait first for the inclusion, and then we'll discuss about that. Just to complete the story, next year we'll have a conference about our tools, including nDPI. So if you want to join, this is the URL. And thank you again for inviting us to give this speech, and we hope that you're going to use this extension to Suricata, because we believe a lot in this Suricata community, and this is our contribution to it. Thank you very much.
So thank you very much for this work. Glad to see it merged, because I guess it was merged yesterday. Just one small question about the first slides of motivation, if you can go back to it. There were some rules, Suricata rules. Yeah, did you try a data set to put many domains like Facebook, FB, CDN, and that kind of stuff? Or?
Not really, because we're going to show you simple examples here. And so this is an example of Netflix. This is a simple one, but there are other domains that are somehow nested. So no, we didn't check that. So if you have to find the name, it's not a substring match, but it's also in the middle. No, so we didn't check that thing you're mentioning.
Okay, so there is a PCRE transform trick to do that, to have like just the last part and all the subdomains, but I guess it's not convenient and we want another transform to get the main domain so that we can use data sets for every domain and subdomain at the same time. Yeah. But thank you for the work.
Thanks for your suggestion and for your support of fuzzing into nDPI.
Yeah, hello, Mark. Nice presentation. Thank you very much. I have a question about scaling. Did you do any tests to test it with higher bandwidth yet? And have you examples of it?
So this particular patch, we have not tested at super high speed because we are waiting for the integration. What Alfredo said is correct, because we are just monitoring the first few packets of a connection. So the very first. So for example, if you have a quick connection, one is enough, okay, just to give you an idea. The impact on the performance is negligible. The main cost here is the memory allocation. So it takes more time to allocate the 1 kilobyte memory structure than to do the detection. For TLS, maybe you need a few more packets, maximum 6, 7. It depends. Usually, if you just limit yourself to client hello, it will be the first packet after the TLS. If you want to extract more metadata, and this is one of the things that we have to put in the config file, you need more packets. Okay, but I mean the performance. It's like I said, at 100 gigabit, not without SuriCata, but with another probe, the increase in CPU was 5% because you only analyze the first few packets at the beginning. And because of this first packet classification that we are introducing, it should be even less and less.
Thanks.
Thanks.
Thanks a lot for your talk. That's really interesting. I see some area like exactly the one we currently showed on screen, where you are redoing the TLS analysis, for example. Is done in SuriCata, then you do your analysis in TLS. Would it be a way to improve the plugin infrastructure so you could reuse the parsing already done by SuriCata?
In fact, this is one of the things that I didn't say. Yes, so in essence, there is some overlap, okay? Because we are processing the traffic similar to what SuriCata does, at least at the beginning. And one of the things that we would like to do after this is merged is do this. For those protocols that are supported by SuriCata, we should rely on SuriCata. But on the other hand, if I have to detect HTTP, we have already done most of the work. But what you're saying makes sense. Yes, you're right. So we want to rely on SuriCata for those protocols. The same for the patch we did on Wi-Fi. Yes, it makes sense. And going back to your talk about the fingerprints, inside the library there is something more than JF4. For instance, we have the TCP fingerprint for detecting the operating system, or we have the fingerprint of RTP. So you can know if this is a Zoom call, Teams call, or whatever. So another addition would be also to understand if it's possible to inject these things into SuriCata for the detection. I mean, but again, first let's wait until the patch is in, and then we'll discuss about that.
I have a question around some more like operational questions. So I imagine you're using some kind of a database of information that lets you classify traffic against in order to tell protocols and whatnot. So as an operator, how do I keep that information up to date? I imagine it changes somewhat frequently. So is that a database that's separate from the module that I can update regularly, like without restarting the process, or how does that work?
No, there is no database. Let's say, so nDPI uses several techniques for detecting the protocol. So some are implemented in C because they are dissectors. For others, we use the IP addresses. For others, host names. So let's say everything is inside nDPI, the nDPI library. So in order to update it, we have to update the library. We have repositories, of course, with the library already pre-built. So you just run a apt-get update and you get it.
Let me add something. It is possible to do that, not in the current implementation of SuriCata. As I said, it's part of the to-do list. So in essence, you can reload a protocol definition. Just to make an example, you cannot define Netflix 2, let's say, suppose they exist. But you can reload the definition for the protocols for which there is a database. So for instance, for known protocols, like such as, for instance, Facebook, okay, or Microsoft Office 365, okay, you have two options. Either we decode the protocol, or we use the database coming from Microsoft. Inside nDPI, there is a script that allows you to rebuild the database, okay? So this is possible, but in the current implementation, it's not possible to update nDPI while Suricata is running. It will be possible in the future, because in our tools, in essence, we are swapping the instance. I mean, so this is not available today, but it will be available in the future. It's part of the nDPI design, not for the built-in protocols. I mean, if you want to change a bug, fix a bug on TLS, you have to reload the library.
Thank you guys, I really like this work, and so I'm looking forward to all the future steps. I guess I have a question on the utilization of this technology in the security domain, because I've always been a bit hesitant with what I know of DPI libraries, where they are more about labeling and not so much about being super robust against evasions and such. And so I wonder, like there's protocols where if you first start talking SMTP to a HTTP server and then you follow up by HTTP, it will just work, right? And so if you then only detect the first couple of bytes as SMTP, you may get bypassed. So to what extent do you think this is suitable for actual security controls or more for, let's say, annotation and post-processing?
Based on the design of the tool, depends on the protocol. There's not a single answer. So for instance, SSH, if it starts as SSH, it will be SSH. But the typical example is WhatsApp. Okay, WhatsApp starts with a certain protocol, and then it becomes WhatsApp, the real WhatsApp. So what can I say? I agree with you. So for security, a proper dissector, similar to Wireshark, to Suricata, is necessary. But for most of the modern protocols, I mean, not those that document in an RFC, I mean, what we can do is just to do what we have done for Skype, for other protocols. I mean, you use some packets. For instance, for RTP, we probably need more than 8 packets just to check whether the protocol is changing. But if you want, you can use it as an annotation. You're right. But again, depends on the protocol. TLS cannot become something else. But I don't exclude that in the future this will be possible. In fact, based on the protocol, so whenever we see, for instance, a detection of a VPN, we wait a little bit longer, and we report that we believe this is a VPN, but we say, we are not yet ready, okay, please give us more packets until we decide that this is really a VPN. This can happen. So for security, I think that is based on the protocol, the fact that whether it can be an annotation or a true fact. This is true. Because, I mean, packets don't have any kind of security. You can craft packets. We have seen tools, in the previous days that can do that. Yes.
So one thing that could be interesting would be to expose that confidence level of the detection to the rule language, so that rule.
Or maybe it can become a configuration where you specify if you want to detect only protocols that you are sure it's not going to change.
Yeah. Confidence is there. So for instance, when we detect a protocol, let's say Office 365, okay, we can report whether it's detected because we dissected the packet or because the IP is listed by Microsoft as. So it's part of that. But again, this doesn't change the idea behind your question that is right. So it might be that a protocol, we are sure it is this protocol, but then eventually after 20 packets becomes something else. This can happen.
Right. Now that I think of it, does it still work? Yeah. Now that I think of it, I could see even more issues, like for example, the flow update callback that was created will not consider any type of TCP anomaly. So Suricata may actually, in its own stream engine, reject this packet because it's injected or broken or something like that. But this will still be passed to your callback because it's invoked before. So maybe we need to consider a bit deeper callbacks for TCP so that we at least have done the Suricata security validation before it's passed to the DPI engine. Yeah, so yeah, there will be a lot of work, but yeah,
Yes.
very interesting work. Thank you.
Thank you.
Thank you. Thank you, guys.
Quick question.
Juliana, David can ask this question.
Sorry. Quick question. Out of the 500 or so protocols that you can identify, what percentage of those rely on dissection, and what percentage are a little more than just host name and port number based?
Let's say most of the protocols are relying on these sections, if not all. Okay, but we have also the ability of having, let's say, nice to have information such as the example for Tor egress nodes or for Office 365 or for Facebook, to say, okay, this is what we believe it is, so DPI, but it is also confirmed by this whitelist. Yeah, but most of them are based on DPI. Let's say we don't decode a protocol because of an IP. So if it's because of the IP, it's because the DPI has failed. Maybe the flow was started when we started the engine, or we have been unable to decode it, and then we say, okay, we don't know what is this protocol, but we believe it is this protocol. For example, if we see TCP port 80, and we are unable to see that it's HTTP, we can display here. I don't know if it's gone. You say it's a guess. So we are saying this is true because we have dissected, or this is a guess, or this is not DPI dissected, but it is part of a list that is part of the application. There are many lists. If you go to GitHub, there are many lists. I mean, we have at least 20, 30 lists. Because companies from time to time provide those lists because of the firewall. They want to make sure that the firewall doesn't block those IPs.